Hi everybody, my name is Cameron and today we're going to be looking at electricity, specifically alternating and direct currents, power and voltage, and different appliances. So starting with the different types of current. Okay, we know that current is the force that is pushing electrons through a circuit. Now you can either have a direct current which flows in one direction only, okay, or we can have an alternating current. Alternating currents are going to swap directions at a certain frequency, okay, and we're going to be looking into the reason for this thing. Now we know that we get our electricity from the main grid, okay, the grid that is connecting all the homes, all the buildings, okay, and it comes through into a plug. This plug is going to then have to be connected to your appliance. We do this using I guess you could call it another plug. We call it a male and a female plug, okay? And the electricity of most homes, well, in the UK and the UAE, is sitting at 220 volts and 50 hertz. So that 50 hertz should tell you that the current coming into your home is AC. Now, the reason that it is AC is because it's easier to transmit an AC current. It's also a lot safer because if you had to stick a fork into a plug or touch a live wire or something like that, it would be alternating current. So it would just kick you instead of holding you there, okay? Because if it was a direct current, it would just pump you full of electrons and electricity. Whereas alternating current gives you a split second to let go, okay? Now, when it comes to these plugs, okay, we know that sometimes they can have 3 or 2 pins in them, okay? So if it's a 3-pin plug, usually it consists of a earth wire, okay? The earth wire is a sort of safety wire. And what that does is it's going to ground your appliance so that you don't become the ground, okay, for the appliance if it were to malfunction or you were to get shocked. Okay, so how that works is electricity is always trying to get to the ground, okay? It's charged. And charges want to disperse. They want to go into the environment. They don't want to sit in a wire, closed up and compacted, or in a battery. They want to get to ground. They want to get to where everything else is, to be neutral. Okay. Now, it's going to take the quickest way to ground. A lot of the times, that'll be you. If you are touching a live wire, it's going to go right through you into the ground. A lot of electricians will wear rubber boots because it insulates them from the ground. Okay. But in most appliances, we're going to have a ground wire that is going to be connected to the earth so that the electricity will go through there instead of you. Okay. It consists of a neutral wire. Now, the neutral wire does not have a charge. It's just going to complete the circuit. Okay. We can't just have one wire going into an appliance. Circuits need to go all the way around. Okay. And then back to the source. Then we're going to have a live wire. Now, the live wire is usually a reddish color or brown, okay? Neutral is like blue, ground is like a green yellow, okay? But the live wire, red means dead. Brown, I'm sure you can come up with your own rhyme for that one. But this wire will shock you. It is carrying very high voltage. It is going to be attached to a safety fuse a lot of the time. So if there are fluctuations in the power grid, the safety fuse will burst instead of your appliance. Okay. Now, power. What does this mean? Power is the energy transferred through a device over time. Okay. So it's almost like the rate of flow of energy. Okay, so power is measured in watts, energy in joules, time in seconds. Power can also be calculated by current multiplied by potential difference. Now, we've been talking about resistance quite a lot, and we know that resistance is going to lead to an increase in heat energy. Now, what is heat energy? Heat energy is going to be the dissipation of the energy of our object into the environment. So where there's heat, there's friction, there is resistance. Now, resistance can also happen in a circuit, okay? So when current passes through a resistor, the resistor is going to heat up, okay? Because those electrons are pummeling, they're going into that resistor super fast, and it is trying to stop them, but it's not quite working, so it's all going to heat up. Okay, the heat is dissipated to the surrounding as waste. A lot of the times, we try mitigate, we try lessen how much energy is wasted. So light bulbs, for instance, they used to get extremely hot. Ask your parents. You wouldn't be able to touch a light bulb once it's been on for a while. Okay, but nowadays LEDs are, you can't really feel them at all. Okay, because they are much more energy efficient. They don't lose as much energy to the environment to heat. Okay, they just lose their energy to light. So energy equals to charge measured in coulombs multiplied by potential difference. Power is equal to current squared multiplied by resistance. Okay, so these are some formulas that you probably won't have to remember, but they're good to know. Okay, so as we can see here, we are going to have a positive resistance where resistance is causing heat that is going to be dissipated into the environment. Think of like a heating blanket, or maybe one of those heaters that has red coils, or hair dryer. Okay, that would be positive resistance. Then we have negative resistance. Negative resistance is where the environment is actually going to be cooled down as the resistor takes in heat. Okay, you can think of a refrigerator. Refrigerators, interestingly enough, though, are going to have areas that are hot because they are pulling the energy out of the air surrounding them. Okay. Okay. So as I said before, a lot of appliances didn't used to be very energy efficient. It means they lost a lot of their energy to to something like heat, to something like sound. And so this loss of energy to something that we don't really need would lower its efficiency. Okay, theoretically, we would want an appliance that is 100% efficient. If it makes a noise, it only makes a noise. If it makes light, it only makes light. Okay, but there aren't many appliances or any appliances like that, but they have become more energy efficient. Okay, so energy is power multiplied by time. Power is equal to current multiplied by potential difference. We know this. Okay, but the percentage efficiency equals the power output in watts divided by the total power multiplied by 100. And what can happen is a lot of the times, if it's more energy efficient, it's going to have a better environmental impact or less of an environmental impact, as well as lessening your consumption costs. So it's going to cost less if you can use less electricity to power it, okay, because you're losing less to heat of a light bulb. So you might have seen, especially this one on the right here, different appliances will have different grading systems of how efficient they are. Okay, and what you want to do is go for the highest efficiency possible, because that is going to be not only better for the environment, but better for your bank, and the appliance will sometimes be a bit more expensive because of that, but it'll be worth it in the long run. Yep. So look out for this. Try buy energy efficient appliances. Try throw out old light bulbs. My name's Cameron, and I'll see you next time.